So here is yet another operator which is actually a 2-character one, command space 2 greater than space file1. 2 greater than is an operator in which you should not insert another space between them, and what this operator does is to redirect the standard error to the file1. The standard output would be having its default behavior, namely sending it to the screen. The standard end will have its default behavior by reading it from the keyboard, and therefore the only one file pointer is being redirected, which is basically the standard error to the file1. Now why is it useful? We will demonstrate the use of this particular command in a moment. Again, the same warning applies, that is, if the file1 doesn't exist, then it will be created. So you should watch out what is the name of the file, which directory it is going to be created, whether you have permissions for that, whether there is any other useful file already by that name which you don't want to overwrite, and so on. So if you look at this command ls and $home, you would see that the list of files and folders in the home folder are being displayed on the screen, and you can give multiple options to the ls command. So I would say ls $home and then let us say slash blah. Now what happens is that the directory $home has content and that is being displayed on the screen, but the directory slash blah doesn't exist, and therefore there is an error message on the screen. Now both error message as well as the output have come onto the screen, and our objective of using 2 greater than operator is to redirect the output onto the screen but the error onto a file. So we will do that now. So I use up key to retrieve the command back for editing, and I press 2 greater than, and here I need to give a file name where the error will be placed, and I would call that as error.text. Now if you see, the screen output is very clean because it doesn't have any error message, and there is a file called error.text that has been created, and you can actually look at its content. So it has 53 bytes, and cat error.text would actually show you the error that was displayed when it was trying to run the command ls on the directory called slash blah, which did not exist. Now what is the use of this 2 greater than operator? It is two purposes. One is to keep the output on the screen clean so that the error messages are not being displayed for whatever reason. Another way is actually to send those error messages to a file so that you want to inspect that file and understand what errors have come up that you want to debug at a later point of time. You can combine both greater than as well as 2 greater than symbols so that the standard out is redirected to a file and the standard error is redirected to another file. So you could actually try this out so that the output is in one file and the errors are all in another file. And this is a very useful feature because the error file will be requiring our attention to watch out if there was any problem with our script, whereas the output file is something that we may want to keep for our log. Naturally, the warning about the file1 and file2 being created afresh will stay. That is, the directory should have the right permissions for us, and if there are any files by those names, they will be overwritten, and therefore we have to watch out what names we are giving for those files. So now we will try to do this redirection as described just a moment back. So we have ls $home and slash blah, and then we will write greater than and say output.text 2 greater than error.text. Now if I press enter, what do you expect to come onto the screen? Both the standard output and standard error have been redirected. You do not expect anything to be shown on the screen, and that's exactly what happens. And here is again another application for you to imagine that if you do not want any output on the screen and the script has to do its job silently by writing stuff onto files rather than onto the screen, and this is one way by which you can achieve that. Now let us look at the two files that have been created. So the error file has been created 53 bytes, and the output file has also been created 126 bytes. So what are the contents? So the error file naturally has the content which is expected because slash blah doesn't exist. There's an error message for that, and the output file will have the list of files and directories in the current folder of $home, which is the home directory. So that is also as expected. So as you can see, we can actually combine both of these in a very useful manner. So what happens is when you try to look at the ls output in a recursive manner, usually there will be some errors on the screen if there are any directories which you are not supposed to enter because they belong to the system. Now there are such directories available in /etc folder. So let us try that out. So ls -r /etc minus capital R is to recursively traverse that particular directory and just list those files onto the screen. So when you type this, what happens is that it is running, okay, and we can look at the contents of the folder /etc in a recursive manner, and whatever are the directories and their listing, we can put that in the file called output.txt. And if there are any error messages because we are not supposed to enter some of the directories, then that would be made available in the text file error.txt. So when I enter here, I should not see anything on the screen as expected. And let us look at the content of these two files. So you can see that the output file has 54,950 bytes and the error file has 327 bytes. As you can see that the two files have been overwritten from our previous command. So we have to always watch out that the greater than symbol and 2 greater than symbol will always overwrite the files if they are already existing in the current folder. Now let us inspect the content. So I would use the less command to inspect the content of output, and you can see that the files in the etc folder are being displayed here. And for every directory, it would actually list the name of the directory, put a colon, and then the files that are in that particular folder are listed, and it would inspect every folder recursively. And this is a very nice way by which we can actually look at what all the files that are there in that particular directory in a recursive manner. But in the process of doing that, there are some directories which you are not supposed to enter, and so we got some errors. And let us look at that. It says that there are some directories which are not supposed to be entered by us, and therefore we got permission denied errors, and those errors are all captured in the error.txt. We can use the less than symbol or the left arrow bracket to indicate that the standard input has to be redirected. So any command that was expecting the input from the keyboard could actually take the input also from a file if we use this operator, and we can try that out with some commands that we have just been familiarized, such as cat. So let us try that out. So we have some files here. So error.txt is one file that we can try out. So when we type cat error.txt, then it should just display the contents of that file. Now we can actually say cat less than error.txt, and what would happen is that it would read the content from error.txt and display. So the behavior is exactly the same. Now we can test the less than symbol by using the wc command to count the number of words, lines, etc. So we have already seen that the wc command is familiar to us. So normally the wc command is run on a file. So we have seen that we were running it on etc profile, and there are 27 lines, 97 words and 581 characters in that particular file. And if you were to run it on the error.txt, which was created just now, so it has 5 lines, 35 words and 327 characters. And look at the contents, and you could actually make out that these are the 5 lines. Now what happens when we type like this, wc and then less than? So if you type like this, wc less than error.txt, it would mean that the content has to be read from the file, and that would be the same behavior as what you have given on the command line. Here is a very interesting combination of the operators. So here you can see that the greater than operator is telling that the output from the command is being redirected to the file 1, and the 2 greater than is indicating the standard error, and that is being redirected to the first stream, which is standard out. So what is happening that the standard out also is going to the same file. 2 greater than indicates the standard error, and the ampersand and 1 indicate that it should be redirected to the file pointer 1, which is standard out. It means that the standard error will also go to the same file, file 1. So here is a very neat situation where the output from the command as well as the error from the command are both sent to the same destination file, which is file 1. The usual warning about the file 1 being overwritten and permissions to create that file should be provided, etc. will apply. Now let us look at the application of the command that we have just now illustrated. So we have got the example here. So ls $home / blah. So we saw that this command would have two outputs. One is the standard out, which would be the directory contents of the home folder, and the other output is to standard error, which is basically the error that the folder / blah is not available. Now we would like to combine both of them to a file. Now what happens when we do like this? So what happens is that the output alone is sent to the file 1, but the error is not sent, and that is coming onto the screen. Now what happens when we do like this? So we have sent the output to the file 1, the error also to the file 1, but does file 1 contain both? So let us look at that. And you see that the file 1 doesn't contain both, it contains only the output. The reason is that the error actually has come out first and it was written to the file 1, which is then overwritten when the output is being redirected to the file 1. So if you want to have both the error as well as the standard out to be redirected to a file, then you can't actually use this particular format, because the file created by the error redirection would be overwritten by the output redirection. So for that, what we need to do is to redirect the error onto the out. It would have no overwriting happening. So a better way is to redirect the standard error onto the standard out, and then let the standard out be redirected to a file, and thereby there will be no loss of the content that is being stored as file from both the streams. So we will try that out now. So that is a command, and as you expect, nothing should be on the screen because the error as well as the output are both redirected to the file 1. So nothing is displayed on the screen. And let us look at the contents of the file 1, and you could see that the error message as well as the directory listing of the home folder are both in the same file, file 1. So this is a very useful feature where output from the command, both the standard error as well as the standard out, are both redirected to a file which you may want to look at later on to debug if the command happens to be fairly complex. In this case, it is a simple command, but you could actually have a shell script in the place of the ls command, and this kind of a redirection could be very useful in debugging what's happening to the script. So just to recap, we are redirecting the standard error onto the standard out, which is then redirected to the file 1, and therefore file 1 would contain both the outputs from the two streams, namely the standard out as well as the standard error. Now comes a very powerful operator called the pipe, where the output of the command 1 is sent to the command 2 as an input, which means what you are doing by this pipe is the standard out is being mapped onto the standard in of the command 2. If command 2 was expecting any input from the keyboard or from a file, then it could actually take it also from the output of a command 1, and thereby you could actually combine the two commands in order to process the output of the first command as an input to the command 2. Now this is a very popular way of using the commands, because it allows us to combine multiple commands for processing without writing to a file intermediately. Now we have not talked about the standard error. By default, the standard error would actually go to the screen, and that's how we are actually showing it in the graphic. So let us illustrate the use of pipe command. So let us say we would like to count the number of files in the directory user bin. One way is to redirect the output of ls command onto a file and then count the number of lines in that file. So we have redirected the output of the ls command onto the file 1, and we are now running wc on file 1 to count the number of lines, and we see that the number of lines is 2596. Let us look at the file 1 itself. It contains the list of files that are there in the directory called user bin. Now here what we have done is to write the output to a file and then look at the number of lines in that file, which is not very efficient because we are actually writing a file and then again reading it. So we could actually do it in the memory where the output of the ls command is mapped as an input to the wc command. So that's exactly what the pipe does. Now you see that the operation is much more efficient and we are getting our answer straight in one go, and there is no file 1 that is created. So this pipe command can be used to combine multiple commands, and this is one of the most popular ways of combining commands on the Linux shell on the bash, and very often complicated commands involving several pipe symbols on the single command line are very much possible. Let us say I would like to look at the files that are in the user bin folder, but I would like to scroll through them and I do not want to write to a file. So I could also do that now here. So ls user bin, and I can pipe it to the command called less, and you could see that it is now available for us to scroll through up and down, and when we are done we can press Q and come out. The list of commands in the user bin directory are now not written to a file but are sent to the less command by a mapping of the standard output of the ls command to the standard in of the less command. Thereby the mapping is in the memory and therefore it is very efficient. Now we can actually combine both the pipe as well as the greater than symbol to combine multiple commands as well as files as destinations for the standard output. So here is again a very popular usage where the command 1 is actually combined with the command 2 using a pipe symbol, which means the standard output of the command 1 is mapped over to the standard in of the command 2, and the standard out of the command 2 is then redirected to the file 1. However, the standard error of both the commands is still shown on the screen by default because we have not done anything with those two file pointers. Now naturally the file 1 has to be created afresh because the greater than symbol would actually mean that it has to be created afresh, and so if that file exists earlier then it will be overwritten, so watch out for that. We can try out an example to illustrate how this can be done. So have a look at the following command that we are going to do a demo. So let us say we would like to list the number of commands that are there in the user bin folder and write that output onto a file so that we could actually use that file for some other purpose. So if you were to do like this, ls user bin pipe wc minus l, that means that the number of files in the user bin directory are being listed, and greater than and then file 1. So what would happen is that file 1 would have the number stored, which means that we have done two actions here. One action is the standard output of ls is passed on as the standard input for wc, and the standard output of wc is redirected to the file called file 1. The file 1 has the content, which is basically the number of lines that has been counted by wc, which is the number of files in the directory user bin. There is a file in the /dev directory. Normally we don't go there to fiddle around with those files because they belong to the system and some of them are very sensitive. So we do not normally do anything with the /dev folder, but there is one special file there called dev null, which is like a black hole. So if you happen to write anything to that particular file, then that content is basically disappeared from the system and it is actually used as a sink. So sometimes when you have confidence that the script is running well, you do not want to have any error from that script to be displayed on the screen for the user, then you can actually redirect the standard error of the command to dev null, and therefore the errors will actually get disappeared into the /dev/null folder, and thereby they will not be seen on the screen, and therefore the shell can actually have a very clean output on the screen. So here is a typical usage. So you have got the command that is running, and it is giving out two streams of text. One is the standard out, which you may want to redirect to a file. But if there were any errors, then you do not want to keep them. You don't want to also show them on the screen. So you can actually send it off to dev null so that it is disappearing. And that redirection of standard error is already seen by us. It is 2 greater than. And the file itself is a special file where it actually destroys that content, and therefore the error messages are not coming onto the screen, which is the purpose of this kind of a command. Now, to illustrate the combination of both greater than and dev null, we have got the usual example of listing of the folders in the home folder as well as in a directory /blah which doesn't exist, therefore it will give you errors. So here you see that the errors have come onto the screen, but also the contents of the $home. So we would like to have only the contents stored in a file called file1, but the errors are coming onto the screen. I do not want them. So what I do is I redirect the error to dev null, and you see that the screen is now very clean because there is nothing on the screen. The output is only in the file called file1, which we can inspect by using the cat command, and the errors have all disappeared into the black hole called /dev/null. We have done this exercise with respect to the recursive listing of directories in /etc folder, where we face some permission errors to enter some directories. So again, here we can do ls -R/etc. We want to redirect the output listing to the file called file1. We would like to have the errors disappear. We would like to have the errors disappear to dev null, and you see that the command has executed in a very clean fashion, typical of a Linux command. And you could look at the file1 contents. It would contain the list of files in the etc folder recursively, and the errors have all gone to dev null. So that is a very clean behavior of this command, and this is a very typical usage of the two symbols greater than as well as 2 greater than. Now here is yet another command which helps us in organizing the file streams in a very clever fashion. The T command, what it does is like the T shape. What it does is that it would actually split the standard output into 2 streams. One stream is redirected to the file1, and another copy of that stream is then sent onto the screen. So this is used in situations where you would like to have a copy of the output stored in a file but also sent to the screen. So which means that you could then further do another processing by writing something else after the T command. So we can see how it is used by some illustration. Let us test the T command once here. So we look at the help for the T command. What it says is that it would read the input from the standard input and write it to both standard output and any file that has been specified. Okay, and it is using plural, so it could actually write to multiple files. Okay, and because it is reading from the standard input, you could actually put the T command after a pipe so that the output of one command is sent as an input to the T command, which it would actually put it on the screen and also write to a file. So we will try that out using our favorite command, very simple command, ls $home and pipe T, and then we write a file called file1. So you see that the contents of the file1 would have the same thing what is on the screen. So you can see that the output is the same, which means that the T command has placed a copy of the output of ls command in the file called file1, and it is also sent it off to the screen for you to see. Now what happens when we give 2 file names? So you could see that cat file1, cat file2. So it has written to both the files, which means that the T command is useful in sending multiple copies of the standard input. Whatever input is coming in, it would actually create multiple copies, one to the screen by default, and another one to the file1, another one to file2, and so on. Now what does it do to the standard error? So that is something again we can inspect. So here we are actually confident of raising an error, so because /blah doesn't exist. So when we run this command, you see that the error message from the /blah is coming onto the screen, and the output is slightly different here. The name of the folder is given with a colon. That is typical whenever the ls command has multiple folders being listed, so each of them will have a colon, so that the file listing below is for that particular folder, and the folder listing is here for the home folder, and we can inspect the contents of file1 and file2. So cat file1, it has the listing of home folder, and cat file2 also has the listing of the home folder, and look at these files. So file1 and file2 have the same amount of data. Let us even compare the two files. There is a command called diff. So diff file1 file2, and there is no output, which means that both of them are identical files. So let us look at the help for the diff command. It says the diff command does by comparison of files line by line. It is very useful to understand. So what it does is that the t command has given two copies of the standard output on file1 and file2. Both are identical, and the same content has also been put on the screen for you to see. Now you could also pass it on to another command beyond that. So you could actually put a pipe after that and put wc minus l, so counting the number of lines in the directory listing. So now you see that the error message has come onto the screen. The number of files in the home folder are counted as 14, and two copies of the ls command output are placed in file1 and file2. Let us verify that. So you could see that file1 and file2 have two copies, and when I run the wc minus l on file1 as well as on file2, you see 14 lines because that has been counted by wc, but it is not counting from these two files, but actually from the output of ls command, which has been passed on to the screen by the t command. So you can see that the t command helps in keeping a copy of the output in a file and also send it to another command that may actually process it further, because it is sending it to the standard out, which can be redirected by the pipe symbol to another command. So that way you can actually combine multiple commands on the command line by using multiple pipe symbols as well as the t command to keep copies of those outputs intermediately. Now we will suppress the standard error message that has come here by using the 2 greater than symbol. So let us do that now here. So I should do it here because here is where the error is raised. So I would send it to the dev null. So now you see that the number of lines has been printed on the screen, but there is no error message on the screen. That's pretty neat. Okay, and we also have two copies of the listing of the home folder in file1 and file2 respectively. So this is a pretty neat way of combining many things. You can see that what we have done, we have given the redirection of the standard error onto the black hole called dev null. We have piped the output to t command, which has copied the output to the two files, and then we have piped the standard output onto the wc, which has counted the number of lines. So like that you can assemble multiple commands to achieve a very complicated task. Now as you can see that we are able to combine the operators as well as multiple commands and file names to achieve fairly complicated task, where we have one command creating an output which is then passed on to another command as an input, which is then passed on to a file to storage or to yet another command to do some more processing like counting the number of lines, etc. So each of these commands can actually be a bash script, which is where you can start imagining that you can actually create a very complicated task to be achieved by the command line as well as multiple commands being placed in a script, which we will be learning shortly.